Creating new business value by applying analytics to the rich stream of new data the AMI system delivers is a key pillar of today's smart metering business case. Analytics, with particular focus on grid-side applications, have been a key area of focus and R&D investment for Itron, and we've developed a robust platform and suite of applications that leverage both our capabilities in advanced metering and our knowledge of utility operations to create new and distinctive value for our customers, especially on the distribution side of the utility. Smart meters are not just cash registers, they're grid sensors. Their ability to deliver precise and timely voltage data, outage alerts, including momentaries, and detailed load data gives distribution system operators an entirely new range of awareness and insight that extends all the way to the customer premise. Here are a few examples of the ways that Itron combines its OpenWay solution with analytics to help distribution operators run a safer, more reliable, and more efficient grid. In this scenario, we're evaluating the impact of additional load on an existing transformer. The customer intends to add load at their residence and has called a planner who will now investigate the request. From the system-level dashboard, a planner can view a summary of voltage, load, and outage information for the premise. To investigate a specific service point or transformer, the analyst enters the ID from anywhere in the application. The planner can view the account in question and its relationship to neighbors and the electric circuit. Load and voltage profiles are shown for any period of time, giving the planner historical data to consider. After a review of the location in question, the planner navigates to the transformer serving the customer. The planner then uses the load evaluation tool to evaluate the impact of an additional fixed load or hourly load profile to the transformer. In this scenario, the load addition will exceed transformer rating, and the asset would likely need to be replaced. In the next scenario, the application continually monitors transformer loading across the system and alerts planners to overloads and excessive loss of life conditions caused by addition of electric vehicles and other unreported load increases. The Transformer Load Management Dashboard provides an overview of the planner's area of responsibility. Key performance indicators summarize overloads and provide quick access to a list of overloaded assets. Markers indicate distribution transformers that have exceeded nameplate loading or have experienced significant loss of life. Zooming into a specific area provides the planner with granular visualization of load on all transformers by a color-coded heat map. A slide control allows the planner to view specific load ranges to target either under or overutilized transformers. The planner then drills into detailed loading and voltage information for any transformer or its connected service points, giving him or her detailed insights about its utilization and loading condition. In this scenario, one service point is responsible for the majority of transformer overload. In this scenario, a planner receives a call from a customer with a voltage complaint. The planner investigates voltage readings at the location and surrounding areas to validate the customer's claim. The planner navigates straight to the customer location by entering the service point ID from anywhere in the application. A map shows the location of the caller with the complaint, as well as other voltage anomalies in the vicinity. The planner reviews detailed voltage and usage history for any service point or transformer, as demonstrated earlier. For a more comprehensive view of voltage trends, the planner reviews voltage levels throughout the entire circuit. Symbols indicate voltage at each service point, while locations that exceeded high or low voltage thresholds are indicated with markers. A slide control enables the planner to dynamically visualize voltage levels across the circuit. The planner is able to select any service point or transformer and review detailed information. In this scenario, an operator or engineer needs to calculate the load they can shift from an overloaded circuit to an adjacent one. This example demonstrates how the application combines AMI data with GIS circuit models to accomplish the task. The operator selects the overloaded circuit and chooses the date range when overload occurred. Hourly load profile data is displayed for the selected day. The operator or engineer can choose between kilowatt-hour usage and kVA demand displays. To calculate the load that can be switched to another circuit, the operator can select all service points downstream of the switch by a trace of the GIS circuit. Once selected, the engineer updates the graph, to reflect the portion of load that will be served from the adjacent circuit after switching. Peak load and time of day are clearly visible in the graphical results. In this scenario, we'll examine the grid reliability application, which provides engineers and operators with a summary of outage activity throughout the system and the tools to investigate root causes and the customers affected. Customer interruptions are classified as momentary or sustained depending on their duration and displayed on the system map. GIS connectivity is used to aggregate AMI events to their parent transformer, then to the circuit and the substation depending on the extent of the outage. The worst performing circuits are summarized in a column chart so the engineer can navigate directly to those of most interest. In the feeder detail view, the engineer can review a time series playback of the outage as it occurs, or similarly for restoration events. In this example, service points are highlighted as the power outage notifications are received. With 1 second granularity, the operator can see exactly when the notifications were recorded at each meter. Analysts can choose playback intervals from 1 second to 1 hour for this data. A line graph provides a different view of the same information, showing the number of customers interrupted at any point in time down to the second. Smart meters are much more than simply cash registers for the utility. They are integral, sensing parts of an active grid that deliver precise, timely data. That data, when combined with Itron's OpenWay solution and analytics, give your distribution system operators the awareness and insight they need to run a safer, more reliable, and more efficient grid.